Hello. So this is going to be a brief tutorial, or maybe even an approach if you don't want to call it a tutorial, for anyone who has come across Unity's web request and how that works, and are wondering, well, I'm familiar with web development. I want it to look like Ajax, something along these lines, where I've got a path, some data, and then the response function. So when the data comes back, I can do some stuff. So with a little bit of wrapping, we can make Unity's web request work pretty much the same way. So first, let's quickly go over the Unity example. So this was pulled from their documentation online, and this is what they have. So the request essentially is this upload function, and it's an enumerator. And the reason for all this, if you've tried to use the .NET libraries, like system.net, and then just send a web request that way, you're gonna freeze Unity, because the frame thread is gonna be waiting until that response comes back until it gets to it's not gonna go to the next frame until that response comes back. So that's what this yield return is for. They've got their the async pretty much handled for us, and of course it's a coroutine, so we have to start the coroutine. And initially you might be thinking, geez, what the heck is all that for? But we can pretty quickly wrap that up and make it look like the Ajax that's a lot easier to work with. We don't want to think about coroutines and doing all this stuff every single time. So what this will look like at the end is, here is our wrapped Ajax-like approach that uses Unity. So when we start up, we get our request meatball get, and then we just call API request, and we provide the data, and then we provide a function. So the response, and all of this is strongly typed by my choice. If you don't like that, you don't have to do that. But in our response in this case, because it's this type of request, we know that our response is going to be a meatball. And then when we get that response, we can log what kind of meatball we got. The return true, again, just another thing. You don't necessarily need to do it this way or that way. This is just to get you thinking about what works for your project. All right, so let's go into our little wrapper here. So we've got a wrapper called API. We've just defined our domain so that we don't have to type things out every time. Our request, this is our public facing method. So this is what we were calling from the startup script. And notice that we have an abstract request base. Again, my choice. You can fiddle around with this and do whatever suits you. And then we have our callback. So this is the code that's going to run when the request finishes. And here we're starting to get into the Unity sample again. So we start our coroutine send request. So if we go down to send request, again, it's an enumerator. So, and we're just passing through the request data and the callback. So what we're going to do is we're going to build our endpoint. I've got the request base has a method here, get request path. So you can define your API that way, or you could split this up into different methods. Again, whatever works for you. So we're going to serialize the request first. I'm using Newtonsoft. It tends to just be a lot more flexible than Unity's JSON utility scripts, but feel free to use those. Again, we're just following their example. So we create a new request. We're going to post because we've got some data. We need to give that a URL, our data, and the type, which is JSON for us. Then we yield return the send web request, and this is not going to block, so your game's not going to freeze when this is all happening. And then If there's not a success, we can log the error, just like the Unity example. But otherwise, we're going to get the response, which is just text. We're going to deserialize it into whatever type. And then we're going to, if the callback isn't null, we're going to run the callback with the response. So if you're wondering what this generic is for, that's the reason why we can say we can strongly type the response to be meatball. So hopefully all of that is enough to give you a little bit of an idea on a different approach to doing this. Again, there's as many ways as you can think of to wrap things, and this is just I would call it Ajax-like. There's anyone's wondering, the controller that we've got this example with, just complete default from .NET when you go to Visual Studio. If you had a project and choose ASP API, it'll come up. We just add our own controller here, giving it the path root meatball get. So all together, that's going to be our URL. And this takes the request that we send from Unity. It just generates a random meatball and returns that for us. Another thing you can do here, again, up to you, but you can, the way we've done like the abstract request, you could also do an abstract response, but that gets a little boilerplate heavy. You know, how many request and response contracts do you want? Some people like them, some people just want to do as little typing as possible. So if we go through all of that and we come back to our startup script, we can hopefully understand what's going on here a little bit more. So in our case, the request meatball, we don't really need to give it this, but just show you this is why you might make a request. It defines the endpoint that it calls as well as the data. The request wrapper, the API wrapper, so our request, we send the data, we send the response, and then this is our callback function. Alright, last but not least, to just prove that it works, we've got our API just on an empty game object here along with the startup script. And when we hit start, we'll look at our console and there we go, we got a spicy meatball. With tools like Unity, they usually have their own libraries that may or may not be a pain to work with, so this example is pretty nice. Pretty nice way. You can usually wrap just about anything to get it to work pretty much any way you like. So don't underestimate the power of just writing a quick little wrapper. Like I mentioned at the beginning briefly, this is more of like an approach video. It's not a tutorial or a best standards thing. It's just to get you thinking about different ways to do things. If you made it this far and you liked it, let me know what type of approach you'd be interested in next. And it doesn't necessarily need to be Unity.